So yeah, we got 2 lectures left after this, and that's next week. That's the last week of classes. That will be just nothing but final review. All right, we'll just have 2 review lectures. I got some ideas about what to talk about. We'll go over some things, and that'll be that. This lecture for today is not anything I'm going to test you on. Maybe I should say that somewhere. Insert. Can I do like some cool banner icon thing? That one. Whee! I won't test you on this. There. I'm not going to test you on anything I'm talking about today. This is just for your own knowledge. You're going to need to wean yourself off of the data science library when you get to a future data science class, because the data science library was just made for the textbook. It was made hand in hand with the textbook that we're using. It's not something that people use in the real world as they do their data science. And so we're going to talk about, what do they use then? It's a different library. It's a different library that, looking at the way that Berkeley structures their classes, the next class that you would take at Berkeley, if I looked it up correctly, would be teaching you this alternative. Like, you go straight into the new one, and they try to get you over there pretty quickly. So at least I'll give you a quick introduction to all of that, and then I'll also talk about databases. So those are the 2 things that you're going to deal with, because as a data scientist, you're going to be interacting with the database. And so there's a language that you have to learn called SQL is the acronym, but everybody pronounce it as SQL because they're lazy, I guess. And so I'll teach you that too. So I'm just going to say a bunch of stuff today. If you would like to follow along, it's just a pre-made set of things from at least the first part. There's a pre-made set of things from Berkeley. We can add to it, but you can have it now if you want. If you would like to go to the not written nice page, if you'd like to go to the code from class page, you now have a notebook called Data Science to Pandas. That's a cute name, and that's the name of the library. That's the alternative to data science. That's the one that they're using in the real world. So yeah, are we ready? Learn about pandas. It's a cute little name. So yeah, I don't have many slides. So you already know. So in the real world, out in the open, data scientists, they're using they're taking all their data, maybe from a database, which we'll talk about next, but they're bringing it into some 2-dimensional grid of labels and columns like we know and love from our data science library, but they're arranging them and asking questions about them using the pandas library. It's such a cute little name. I don't remember what it's probably like an acronym for something, or it's like a shortened version of something. Pandas library. Dun, dun, dun. Let's look it up their Wikipedia page. Does it mean anything? History. It's derived from the term panel data. So you got a bunch of panels of data, perhaps. So that's what it is. It's 17 years old. It's a very old library, and everybody just kept on adding on to it, and everybody loves it. So they use that one. That's their alternative to the data science library. I'll show you how to do equivalent things there. And then once you get down to the columns and like you're filling in things, they're still using the NumPy library that we know and love to deal with arrays. So that's something you already know, which is nice. The one thing that they don't have that was part of the data science library for us was that make _array. That was part of the data science library. So that's not actually part of NumPy. You have to say something like we did in this chapter 17, like np.array, and then you give it some stuff. That's the alternative. You give it some stuff as a list. So that's really the only difference. So yeah, let's go through this file and take a look at pandas. So instead of like, we say this to get all the data science stuff from data science import star, import everything from the data science library into our current, it's called a namespace, so that I can use it. So like, instead of having to say, if I didn't do that, if I just said import data science, and I didn't do this one, then like make array, for example, would have been data science dot make array. Remember how that's happening when we use NumPy, like np dot mean, all that stuff. So import star just means make it so that I don't have to use the dot. So that's the first thing. We have been a little kind to ourselves by doing that. Pandas, people import just like they import NumPy. Say import NumPy as NP, and they say import pandas as PD. Panel data, I guess, and then everything else is the same. So yeah, you can read these words later if you'd like. There's some, the documentation pages for everything. Here's the pandas documentation page. Like there's an introduction page for that. You can search for pandas tutorial. But I just kind of want to go through this file, and we'll look at a very simple data set. We'll look at our ice cream cones data set, and we'll go from there. So yeah. In our data science library, we know that it's table.read table to read a CSV file into a table. For us, it's a capital table thing. But in in pandas, it's called a data frame. They call their tables a data frame. It's a frame of data. I don't know. It's like got panels and things, right? It's like the panes of a window, if you think about it that way. So their version of a read table is pandas library pd dot read CSV, and then it gives you back it's called a data frame. All right, so we've got that, and you can ask it to have those things print out. So like the data science version is like, hey, here you go, my table. That one, the data frame version, it's like, okay, print that one out. It still has a pretty way of printing things out, but you see that there's slight differences. It shows you indices here as well. It's the one new thing. So that could be important later, but yeah, that's how it works. Honestly, I think that deep down, the data science library table is it's made using the pandas library, so it's like calling off to the pandas library secretly, and so that's probably why we see a lot of similarities. So there's that. There's two kinds of things in pandas that people like to use. There's the data frame that is, I guess that makes it bigger, I don't know. There's a data frame and there's a series. So a data frame is the whole darn table with a bunch of labels and columns and things. And then the series is kind of like just one column. They call them series. And you can extract them as NumPy arrays if you want to. I don't remember how. We'll watch it happen together in this tutorial page. But yeah, let's talk about how to make from scratch a data frame, just like we made tables from scratch. Like here's a table. Make it for me, please. We know that we can do blank table with some columns. You give the labels of those columns, and then you give an array of what you want in those columns. So there you go. Here is how you would do the same thing in pandas. I press play, it's still the same. You'd say pd.make a data frame for me, please, and then data equals. Here's the data that's part of that data frame, and then they give it to you in this way. They use curly braces, which you have not seen yet in Python. So let me teach you what that is. I'll add a new one here. So the curly braces is called a dictionary. Curly braces in Python create what is called a dictionary. It lets you store, I'll just type the words and I'll explain them. It lets dictionaries, dicts for short, let you store values associated with keys. So those are some terms that you may have not heard before, but kind of think of it like a phone book. You can say a bunch of things like label names, and you give colons, and then you say what you want to live at that label name. So like a phone book, you could put between curly braces by saying like Lawton's phone number is 1, 2, 3, 4, 5, 6, 7. There's 7, right? And then my mom's phone number is colon 1, 2, 3, 4, 5, 6. She got 6, 6. She was before me. So that makes it's called a dictionary in Python. The type of it is a dictionary. So that's like a phone book. Boop. So there it is. The type of it, we can print the type of it. It is dict for short, dictionary. And the way you use it is you can look up values and be like, phone book, tell me what Lawton's phone number is. So the names are the keys. The things on the left side are called keys, and the things that they store after you enter the key is the value. It's like you can unlock the thing. So phone book at Lawton is, you can get the number out. You can go in and you can save values. Like phone book at mom is that one. So that's how those work. Does that kind of make a little bit of sense? Or just like you're associating things together. Stirs with ints. Didn't have to be just stirs with ints. You could have been like, all right, we live in the future and dad got a phone number. We ran out of integer phone numbers and dad's phone number is pi. Something like that. Like that's fine. Python doesn't care. You can be like, all right, what's dad's phone number now? Let's buy. You can get anything out. But yeah, it's just always you got keys associated with values, and that's how these data frames works. Like you say that the data in this new data frame that I'm making for us is this dictionary. And so here, let's make it kind of look like the call to create a table with columns. Does this still work? Yeah. So yeah, data equals a dictionary of label names, colon, associating them with, these are Python lists, square brackets, because they're just assuming that you can do it that way. You could also have made NumPy arrays, I believe. Just anything that it could go through is fine. So we could have said make array, I believe. Yeah, it's still happy. Anything that it can go through and iterate through, like with a loop, it's happy with. But that was faster than type and make array, just some square brackets. So yeah, that's how you do it. You say, all right, number of petals is one of the labels. Then here's the stuff on that label. Name is another label. And here's the values at that label. Does that make enough sense? Cool. Just shout out if you have any questions. We can look it up together because I am not the world's expert in pandas. But yeah, I just want to show you like the differences because you know and love the data science library. But one day you're going to be forced to use this one. So if you want a piece of your table, like our cones table, had flavor, color, and price, you know that you can use select to do that. Boop. There it is. If you want multiple things, you just use the comma. They made it very nice for us. I want just the flavor and the color columns out of the cones table, please. In pandas, is a little fancier. All right, so remember that a data frame is the grid. It's you got a bunch of labels map into a bunch of columns. A single column is called a series. So if you want to go there, you use actually those same angle bracket accessing stuff as you would for a Python dictionary. So they've kind of taken on that idea, like looking something up using that kind of syntax. That is something that most Python programmers, they learn first, and so they just kind of overloaded that idea to make it easy. But we didn't see that before, so now we're first seeing it. That's okay. So yeah, if you say, give me, I guess I don't have to press play because I already did it before, but give me just the color series out of that table, here's what it does. It looks like this. You get all those pieces. It's still in the right order, it just looks a little weird. It's like the name was color, the data type of the things involved are, it says object because it could have said stir, but I guess it wasn't fancy enough to notice. So there's that one. If you want the series out, just the one column thing, you can do it like that. If you would like another table-like thing, because another table-like thing is like a data frame again. That's not like, this is just like one column. If you want a table, gosh, how can I explain the difference? So like this is, it's the difference between like getting one of those and then just saying dot column color. That's kind of the difference. Do you see the difference there? One gives you the array, and then one gives you another table with just that one back. In Pandas land, this is like getting the array out, and this is like getting another table back with just that one column in it. So this gives you back, if you use 2 square brackets, it gives you a data frame out of it. So that's the deal. Let's see. I hope that makes enough sense. Just the fact that I'm not testing you on this, of course, but just the fact that you've seen it once before should help you when you're trying to learn it again one day. So yeah, that's the difference between those. You can also get out a column kind of nicely by just saying like dot the name of it. If it's just one name, it has no spaces in it or anything. That's kind of nice. Say dot color. Give me that as a series. All right. And then if you want multiple things, you needed to give brackets to say, like, I want to select stuff, and then a list of things you wanted to select, and it takes those out and gives you back a data frame, so like a table-like thing in that manner. So there it is. It forgot about the price. Okay. So yeah, you can also use indices. This tutorial file is going to wait for a second before it teaches you how to do that. But yeah, I hope that makes enough sense so far. Just shout out if you have any questions about any of this. I just want to show you these ideas so that you've seen them once. All right. If you want rows, because rows are like the individuals, the things in the data, right? I want the first ice cream cone's data. I want the second ice cream cone's data. We know that we can say take. We can give an index, starting at 0, of course, to say what we want. We can also give a sequence of indices, like using a range or something, to get back a bunch of rows in order potentially. So this dot take 2, remember that's going to take the third ice cream cone in our cones table because the indices start at 0. This will take the second and the third ice cream cones because it takes index 1 and 2, right? But not including 3. Up to, but not including the end. So those are that's index 1 and index 2 of our ice cream cones table. Let's see. We could also have done it like this, which the book does not teach you. Just like in these slides, they're telling you cool things right now. You could have done it like that if you wanted to as well, but we don't. We don't think of it that way. It's weird. Yeah, that's a thing as well. But now if you have a data frame, how do you do the same thing? You have to use list indexing syntax. It's called a slice. You take a slice out of a list. So let me teach you what that means. So let's say I've got a list, and a list in Python you make, I'll call it like capital L for my list. Let's have it start at 5, 5, 6, 7, 8. So there's my list. It's got 4 numbers in it. I've used the square brackets. Python lists are all over the place once you get out of the data science library. So that's a list. I can, of course I can get the whole thing out by just saying L. I can get pieces of L out by saying indices. I can say L of 1. That's the 6. L of 0. Indices start at 0 still. And this is the same kind of syntax to go in and get something out, just like we did for the dictionaries. That's the first thing. So you can do that. I could say, what else? I could get a piece of this list by using what's called a slice. I would let's say I want the 5, 6, 7. So that's index 0 all the way up to 0, 1, 2, index 2. And you kind of do the same game as you would do in A range. You say up to index 3, but not including 3. And you say colon. I want you to start inclusive at index 0. I want you to end non-inclusive at index 3. And that slices into the list, gives you back a new list. Or it gives you back a view of that list. 5, 6, 7. So if I wanted just the 6, 7, which is a meme these days among the children, if I wanted that, I would say L1 colon 3, right? That's how I would do it. Okay, so that was wonderful. If you wanted the 6, 7, 8, you'd say you'd start at index 1, go all the way up to, but not including index 4, because index 4 does not exist, right? That's how you get pieces of your list. So that kind of makes sense using those indices. Cool. If you wanted the whole list, you just wanted it's a weird thing to want to do, but you want to make a copy of it easily or something. You could say, give me L if you omit things. It defaults to start and end. So take from the start up to index 3, but not including 3. Take from index 1 until the end. Just say nothing at all. If you want the whole list, you say L colon. So from the start to the end, which is kind of makes a copy of it for you. Does that make any sense at all? It's a weird little syntax. But that's kind of like you doing np.arange with actual numbers, where sometimes it's implicit. Implicit index 0 at the start, implicit the size of the list at the end if you don't give it. Okay, so that's why this works. So if you want the first 3 rows, you say, all right, I want to slice into my my table here, my data frame, starting at index 0, going up to index 2, so you say 3 because you don't want to include that one, not including 3. So that gives you those first indices just like that. And it makes potentially a new data frame. So I don't actually know, because you see how it says 0, 1, 2 on the left right there. What if I said this? What if I said 1 to 3? It remembers the original indices. That's useful for checking if it worked or not. I like that. So that's cool. I didn't know that. Now we're discovering the data frames together right now. Yeah, any questions about any of that? Just new syntax. It exists in Python in places that we haven't really learned in this class, because we haven't had to learn that stuff. But that's kind of why they've made those choices. So yeah, that's what the cool kids are using. All right, what else? You can also get You can also use indices in a way called, you can say loc. I guess that stands for location. So this is, all right, I would like the flavor column, every single piece of it. That's how you're reading that. All right, cones.df, I want to go and get rows or columns with a particular label. So I say cones.df dot, go and locate the flavor column, I guess, and give me all the things from the starting index to the ending index. If I wanted just a piece of that, I could have said like go from 1 to 5 or something. Go to those indices. That's totally okay. All right, and that works. Dun, dun, dun. Yeah, I think that's what I wanted to say. So that by default gives you everybody. You can do the same game as we did before to get a couple columns and all of the pieces of it. So again, you say, give me everything from the flavor column and the color column, and every piece of it, please. You can also say, I just want a little bit. Just want a little bit. Let's see here. So yeah, if you want, that's kind of more precise. You have more options there. Give me, I don't know, index 1 to index 4 of the flavor and color stuff together. So there it is. Go all the way. And for a very odd reason that I don't fully understand, this 4 is now inclusive. Notice that. That makes no sense to me, but that was a choice they made. So you do have to watch out for that, I guess. Yeah.
Use brackets for just one thing. So they just put in one index and gives a bunch of error messages.
Oh, like I think you have to give a slice from like 1 to 1. Because you do have to say the colon somehow, I think. I think that's probably the one answer. What else could we have done? Yeah, do you want a piece of a column or just a piece of the...
Just like one row.
Just like one row. I think probably this syntax would make the most sense. Could we do just like 1 on that? Obviously not. I guess you do need to use the slice, so like 1, 2. That gives you just the first thing. That's unfortunate. There's probably a way. There's almost certainly a way, but I don't know it well enough. Let's look at it together. Pandas library. Select a row at an index. We'll figure it out together. So they really like .loc there. There it is. We need iloc, which we're getting to. That would work, apparently. So let's go to that one. Cool. So I guess loc by default and this this bracket give me stuff operator by default, it wants a whole range. But there's a way to just give one thing, and I guess that's what we're about to get to. So it's this iloc thing, which they gave us a horribly long example, but I guess we didn't have to use it like that. So .iloc stands for integer location, and so I think what it's doing is now you can use, in addition to locations on, what's it called? In addition to indices on like of what rows you want, and now suddenly it went back to not being inclusive anymore for the 3, then you can say, I want these labels as well. I want labels 0 through 3. So if I just wanted flavor and color, I should be able to say 0 to 2, just like that. So that's a thing. Interesting. So let's play around with that so that we see what's going on there. And I want to show you how to find more out about this stuff. So I think this would be what we wanted. There we go. So that's how you get one row out. This is row index 1. It's iloc. It gives you the flavor, the color, the price, and it was index 1. Cool. That's good to know. What's the type of that? It gives you back as a series with one thing in it. That's good to know. But yeah, let's look up what iloc does. Pandas iloc. Dun, dun, dun. So you just search for it, and it takes you to the documentation page. Like there's a documentation page for this entire library. There's a whole bunch of things in this library. If you want to go and see what's going on here, you search for it like this. Is there a... Let's make it light mode for us to see. And it's like, all right, iLoc, and you give it stuff between brackets, and you use integers. So you're allowed to give it just a single integer, you're allowed to give it a list of integers, you're allowed to give it a slice of things, that's the word. You can give it some other things that we haven't talked about yet. And then it should show us some examples. So iLoc 0 gives you like the first thing, gives you just a row out. If you give it a list of things, it gives it back to you as a data frame, which is interesting. But yeah, you can kind of see what's going on. If you just give the first thing, it's gonna slice through the rows themselves and give you back a data frame, it seems. We are not ready to learn about that. But you can also talk about both axes. If you give 0, 1, it's like give me row 0, thing 1 out of row 0, index 1 into the row itself. The item is like dot item 1 on top of that. So if I wanted, so we know that row 1 had flavored chocolate, color light brown, price 4.75. We could have said, if I just wanted the price out of that deal, I could have said 1 then comma 0, 1, 2, price is index 2 thing. There it is. So yeah, that's, I guess they've made it less wordy than they've done in the data science library, which is cool to think about. So like, this is how you go through this documentation page and kind of understand it. I hope that makes sense. This is one of those teach a man to fish moments. You have to find what you want sometimes. But yeah, I'm not the world's leading expert on this library, and we're learning it together right now. Yeah, any other questions about that before we move on to other things in the Pandas library? So there's always a way to do something. It just might look a little weird. There's always a way to do something that you know how to do. So yeah, let's do, all right. If you want to rename stuff, we know that we don't ever want to use .relabel because that changes the original table. We love to use relabeled to modify and give you back a new table with a different name. So they've changed the price column to new price. You could relabel a bunch of stuff at once, relabel color and price to ice cream color and new price, like it changes them all at once. We've seen that before. You could have given these as anything that is iterable. So this could have been a make array of those things. This could have been a make array of those things. But as long as it's some sequence you get, it works out. In pandas, you say .rename. .rename. And then the question is, did that modify the data frame? If I say cones df again, oh gosh, where am I? So we run it, say cones df again. Dun, dun, dun. Wait, where are we? Columns later. You see that it didn't. This one gives you back a new data frame, says new flavor. The old one still says flavor. So that's nice. It's just like relabeled. So that's good. That's good to know. You can relabel a bunch of stuff at once by giving a dictionary of what to name what, which kind of makes sense. Go look up this key, and here's the value I want you to rename it to. Go look up this column. You match it with that one, and you find you find it out, and you go and change it to that. So flavor should become new flavor. Color should become new color. The colon makes sense as you would use it in English, kind of. But that's what dictionaries are good for. So that's quite nice. You can relabel a bunch of stuff at once like that. So very similar. It's just .rename now. And so this is going to definitely confuse me as I'm writing the test and remembering these words instead of the data science words. But that's okay. So yeah, at least you'll have the documentation page available to you as you take the final. So you won't accidentally misremember anything. You can always look it up. So, okay, if you want to get pieces out, you do like the .where. .where is very powerful on our tables, right? We love that. So .where, where the price values are above 4, they made it very wordy in the data science library. You have to use the word R for some reason. In the data frame land, in pandas land, it's slightly simpler in my mind, honestly. So like this picks out just the prices that are above $4. If you want to do that in pandas, it's kind of a two-step process. What it does, what you do is you first make essentially, you kind of do the equivalent of you pick out the indices of the cones table or the cones data frame where something is true about them. So remember that here's the entire cones table. If you go into it and you pick out a piece of it, if you say cones table, give me the price column, boop, and then give me, from that price column, go and check them all against 4. Like which ones are bigger than 4? Because that's what above was doing, right? It was kind of doing this greater than operation. Remember that on NumPy arrays, you can do that and it gives you back a bunch of trues and falses. Like, was it true for that row? No. The first one, no, it wasn't. It was not above 4. But for the next row, yeah, the price was above 4. You see that? So you could make this array of trues and falses based on this, this kind of syntax that goes and checks for each element of the price column, is it above 4 or not? So you see how that's essentially what this is doing in a secretly, maybe you can think about it that way. It's like you're really doing this kind of operation, and that's what you would use maybe more of in like an if statement. So the pandas library went hard on that idea. So if you go and you pick out a column, they call it a series. You go into the cones data frame, you get out the price column. You can ask greater than 4 just like as if it were a NumPy array, and it will give you back a series that is a bunch of trues and falses in exactly the same way as we did. All right, so it'll give you back, was it true that the first one, index 0 row, index 0 price, was bigger than 4? No. Was it true that the second price, index 1 price, was bigger than 4? Yes. And so that creates this, and then you can use a series of trues and falses to pick out which indices you want. It'll just give you back all the true ones. If you give this Boolean array, essentially, to the data frame again, you say, look it up using this Boolean array, it will give you back the indices where that was true only. So pick out indices 1, 2, 4, 5, and 6. See that? You give it that array. And so in the pandas land, they essentially just kind of do that all in one line. This is the customary way of doing that. You say, all right, go and pick out the trues and falses, all the places where the price is above 4, and then go and select those rows, because that gives me back a bunch of trues and falses, one for each row. Go and give me the rows where it was true. That's kind of this line. So give me back all of the rows in cones data frame such that all the cones data frame prices for those rows were bigger than 4. See how you can read that kind of? So that's the syntax, and you can use any kind of like comparison that you know and love from like if statement land in Python. So that's what they went hard at, in that direction. Okay, so that's a possibility. Something I think you read about maybe in your book was like and or to combine ideas in an if statement. You can do the same thing, because we did. You can't really do and or on a dot where, can you? If you want multiple things true at once, you say dot where and then dot where again, right? That's the thing that we've been doing. You can actually combine with ands and ors your comparisons in data frame land. You use the single ampersand to do an and you use a single pipe character to do an or. That's the character above your enter key when you do a shift. So that's interesting. So if I want, all right, give me from the cones data frame all the values, so you use the square brackets to pick out things, all the values where the price is above 4 and the price is below 5. See that? That's quite nice that you can do all that in kind of one line. That kind of filtering, selecting out things. So yeah, it's extra powerful if you use or, because it's really hard to do an or in data science land, because you can't. That's not a dot. That's not two dot wheres. It's like combining two dot wheres. Like give me those rows and those rows in a weird way. So think about how you would do a different one. So that's kind of, let me show that to you. Like try to think about how you would do this in data science land. Give me all of the prices that are above $5 or they're below $3. Dun, dun, dun. Let's see. So, oh gosh, I guess there's no below $3. What about below $4? So yeah, these are all the ones that are not, that have no $4 anywhere. It's like, is the price above 5 or is it below 4? So it kicked out all the 475s, for example, which is fun to think about. So that's kind of like the inverse of this one, maybe. You can think about it that way. So yeah, you'd be hard pressed to do that in data science land. That's kind of nice that you could do that so simply. So yeah, that's how you can extract and filter out rows. That's one way to do that. And yeah, next is sorting, right? We like to sort by column, sort by the price column, it goes ascending. It's just called sort underscore values for data frame Pandas land. It's like sort values. All right, give the price column, and it goes in that way. Okay. There is descending. We say descending equals true in data science land. Of course, in pandas land, it's ascending. You say ascending equals false or something. That's kind of disgusting that they made that choice, even though they knew that everybody was going to migrate to pandas after this class. But it's ascending instead of descending, and you have to say you want it to be false. All right. So that's the difference there. And dot group, we love dot group. It lets you do a bunch of things at once. So the cones table, give me honestly, give me flavor and price. You didn't even need that. Group by the flavors, and I want you to take a sum of all the other things, and the only other column was the price column. So it's going to sum up all the prices by flavor. So they're like $15.25 worth of chocolate ice cream options, for example. $8.80 worth of strawberry ice cream options. That's what the group did, right? It combined things in a certain way. By default, it just counted them, but we can collect them with sum. That's a possibility. In Pandas land, you kind of do a similar thing. You get just that data frame with just the columns you care about. So that's give me just flavor and price. That was that one. And then you go in and you say dot group by the flavor, and then you can say dot sum on all the things there. Oop. So let's see what happens before you do the dot sum. What does it look like? Dun, dun, dun. It's not even anything that's printable yet. I guess you have to say, like, what do you want? So dot sum is an option. I wonder if dot len is an option, if that's like the default count. Yeah, dot count gives you that one. Dot sum gives you that one. So I hope that makes sense. So you're grouping by the flavor, every other thing, bless you, that you have not done, and then it gives you the sum of the prices for each flavor. If you say dot count, it gives you how many were there at each flavor. There are 3 chocolates, 2 strawberries, 1 vanilla, 1 bubblegum. So it's very similar. Very similar to what you've seen, just slightly different. Sadly, you're going to have to learn the difference one day. Okay, so yeah, there's that one. We like pivoting. That pivots on 2 axes, right? It's grouping on 2 axes, kind of. And then you can combine stuff in a certain way. So pivot, you say what the columns are. You didn't even have to give the equal sign. That's just like the actual names of those things. But you could have just said flavor, comma, color. And it would have put flavor on the X, color on the Y. And then, like, what do you want to pick out? We can pick out the price. And how do we want to combine prices when they're, like, you have dark brown chocolates together? Like, what do you want to do when you have multiple values in this column, for example? We want to sum them up. Sum up all the prices, please. So, like, there's that pivot table. I hope you see what it's doing. And then in Pandas land, you do something similar. Dot pivot underscore table. Of course, it has to be different. The values on the values you want to pick out are price. The index that you want to go and look at for the y-axis is the color. Just give me only the color column, please. The columns I want to use on the x-axis. I just want to use the flavor, please, flavor column. And then I want to aggregate using the function built in called sum. For some weird reason, you have to put it between quotes. I don't fully understand why. So we can look that up together if we want to learn that more. Like, what are the things that could be in agfunc? That's called the aggregation function. So give me that. Pivot table. Always go look that up. There it is. You give all these things. Agfunc could be, they give them as strings for some weird reason. Function list of functions. Default, it's mean for average. Where are the options for agfunc? Dun, dun, dun. I have no idea. But pandas agfunc options or something. Wow, so they've all been built in as strings, weirdly enough. You give the string sum, you give the string mean. Okay, I guess there's probably a way that you can give your own function that you've made just specific for the thing you want to aggregate by. But you could pass a Python one. But they like to use like their predefined ones as strings, which is weird. But this is their pivot table in the same way. When there is nothing for a column, like for example, there were no white bubble gums, by default, the table, data science stuff, says 0. I'm collecting 0 things. I'm summing up 0 things. The sum is 0, right? That's the default value. Pandas does it a little bit differently. They say nan, which is short for not a number. It just means that there was nothing there at all in the first place. So it's another way of marking that idea. Because maybe you thought that there is a white, like if you look at this, it might make you think that there is a white bubblegum ice cream cone and it was free today. You see the difference? This is making it very explicit. There were no white bubblegums to do anything with. So that's an option. There's probably a way to deal with the nans and like convert them to zeros if you want them to. It's this one, by the way. You can say dot fill na 0 to turn the nans into zeros, but that's kind of useful, I would think. That's kind of cool. All right, so now let's do some plotting. That's one of the last things I think for this one. Let's do a little bit of plotting. We've got, all right, here's a normal table. We've made a table with a bunch of random values. If I rerun it, it makes new random values. Like, give me a bunch of random values taken from this normal distribution with a mean of 1 and a standard deviation of 2, and I want 100 things, 100 columns, please. And then data 2 is a similar value. So it's just making some random numbers so that we can plot them. And then you do the same thing for the data frame land. And so here you can pick out a piece of it. You can get the first 10 by saying dot head. Give me the things that the top things, like chop off its head. Give me the first 10 things of the data frame, and it'll print those out for you. If you did not say that, it would show you some at the start and some at the end. It's kind of interesting to think about. If you just want, if you want just the start, it shows you like that. And then yeah, let's plot that stuff. So we've called it a normal data table. So a bunch of things taken from a normal distribution in a table, a bunch of things taken from a normal distribution in a data frame. So here's the normal data table. You can make a histogram after you select out just one column, and then you say hist with nothing, or you could have said dot hist with data 1. It would have given you that back. In pandas land, you say it like this. You pick out just the data frame parts of the things you care about. So you say, give me just the data 1 column, because there was a data 1 and data 2. Give me just that one, and make that a new data frame. And you say dot hist, and then they said semicolon here, which implies that it would have printed out something as well. Like it kind of prints out it gives you back some sort of array for some weird reason, but if we want to suppress that output, we say semicolon. And so it makes a histogram, and the colors by default are different, but nothing really off there. It's a very similar process. So it's like a select and then a histogram, dot hist. For them, we're selecting in that anyway and doing dot hist. It's not horrible. We do dot scatter to make a scatter plot. We say who's on the x-axis. There's data 1 and data 2, remember? For pandas, you say give your data frame dot plot dot scatter, and then you say who's on the x and who's on the y, apparently. You do a semicolon again to suppress the output, because it gives you back an array by default, I think, again. And so there is its version of the same idea. All right, but it's different data, so it's different random data. That's why it looks different. Yeah, I think that's all that I wanted to say there. Does that make enough sense? It's just like similar names, yet slightly different. That's all. That's all it is. If you want to do bar plots, boop, boop, here's how you do them. In the data science library, you say, you pick out what you want. So here's just a table with some different things, furniture, and then how many pieces of furniture do we have? What is the price of that furniture? Let's just like print what that is. There's the table we just made. We can pick out a piece of that and do a horizontal bar chart of like how much furniture is in, like by furniture as the categorical thing. you can output both the count of those pieces of furniture and the price. That was the example that they made in the book. Cool. Desks are very expensive, apparently. Nice. So that's that. Bar H. It's also called bar H in pandas. You make a data frame with the same ideas, and you say dot plot again, dot bar H, and then you give the categorical thing again with a semicolon to suppress that default output. And the colors are by default different again, but it's exactly the same kind of thing. Okay, so same names, even this time, but it's just like you're working slightly differently. So it's not the end of the world, that jump that you're going to have to make after this class. So that's nice. You can take a table or a data frame that you've made, you can export it to a CSV file so you can use it later. There's a .2 CSV in both of those. There's a way to turn a data science table into a data frame. There's a .2df operation that you could do. And that's mostly it. Let me just show you a few more minor details, and then we'll go to databases. And again, just shout out if you have any questions about anything. We can look up questions together because I don't probably have all the answers, but I'll show you how to learn each answer. So if you want the number of columns, you say .num columns in our data science table. In pandas, you can get out the columns themselves by saying columns.columns, and it gives you back an array, more or less, of those columns, and you can say len on that. So that's how you can get the number of columns. See, it's like a two-step process there. Or there's a shape. There's like a dot shape is also an option. It gives you the two-dimensional shape of that thing. How many? Like it's got 7 rows and 3 columns. So you wanted the index 1 thing of the shape. That would tell you the number of columns. Yeah, number of columns. And the number of rows would be the other thing in the shape, right? So we have .num rows. You could say, give me the len of the data frame. That just tells you the number of rows. That's nice. Or .shape index 0, because index 0 of the shape is number of rows, like number of rows, then number of columns, just like a matrix if you've taken a linear algebra. So that's quite nice. It gives you in that order. Yeah. So there's that one. If you want to apply functions, it's very similar. You say .apply name of a function to, and here's the column that you want to use as the input, like around all the prices up or down. In the data frame, you do the same thing. You pick out just the price series, and you say .apply the round function to each element of that series, and it gives you back a new series in that way. Okay, that's kind of cute. Very similar. Let's see, and you can mess with things. You can rewrite back to them in that way it's saying down there, so I'll let you read that later. Joining, oh gosh, here's a lovely example. So there's, why are we doing it like this? I guess why can't we just do table.show? And then table2.show. I like that better. We don't need to do any of that. This is me updating the way that they taught this in Berkeley. Okay, here's 2 tables. You can join them together. You can join the first table, table called just table, using the first columns and the 4th column. So it's taking all of these and all of these, and it's trying to align them whenever they align, it seems, 1st and 4th. So where do they align at all? It looks like there's A's. There's one with A's in common. And so that's what join is doing. It's taking these ones together. So you see A, J, I, and C, it skips the one that was the second one. So that's an example of join that's very contrived. You do the same thing in pandas land by saying, this one you do have to print in this way, I guess. Let me make another space. So I made the same table again, and then you can say .merge. Merge them with the first on the left and the 4th on the right, and then you do it. It's called an inner join. There's different kinds of joins actually. The default one that we learned about is called an inner join. That has to do with databases, which you'll learn more about, but it does the same thing. You say it's just called .merge, and you have different things. And that's honestly the entire set of examples. So it's called the pandas library. You can look more into it. You can read a documentation page or go through a tutorial. It's not horrible. It's just you say import pandas as PD and go on with your life. So yeah, I think that's what I wanted to say there. Are there any questions about any of that? So I'm not going to test you on it. It's just something you're going to need for a future data science class that's taught in Python, at least. That's what everybody uses in Python. So yeah, the only other thing I want to tell you about today is databases. So there are a bunch of different kinds of databases. Some of them don't use SQL. First of all, SQL stands for Structured Query Language. It is a very old thing. You can look it up together. SQL. Boop. Go to the Wikipedia page. So it's legitimately pronounced either SQL, that you say out the words, or you say SQL. Most people that I've been around say SQL. It's a way to talk about data. All right, it's a domain-specific language, and there's a bunch of different databases, and you can all talk to them using SQL. All right. If you scroll down, there's a very long history. It first appeared in 1973, and nobody's thought of a better way yet. Everybody still agrees that we love SQL. It's just it's a kind of language. It's very simple. And are there any examples on this page? That's kind of ironic. There aren't really. Like here's some examples, some stuff. We'll get to that. But yeah, it's just a wonderful thing. There's a bunch of different kinds of databases. It's usually made to talk about relational databases. There are non-relational databases, which are a little scary. But I will teach you the way to interact with the majority of relational databases. And the simplest database format that we could use is called SQLite. It's very simple. It's on every single device that you own. There's a SQLite database somewhere. For example, if you have an iPhone, your Messages app stores the messages in a SQLite database. So that's worth learning. I assume the same is true on Android in some way. Like every app makes its own little mini SQLite database because it's just so useful and efficient. But there are a bunch of different kinds of relational databases. Probably the most popular one these days is called Postgres. There we go. A bunch of these guys. These are the popular relational databases these days. Microsoft has one. MySQL used to be the most popular one. Like that's what the internet was baked around. Like Facebook was designed with MySQL in mind. I think they're still forced to use it because they've made a bunch of decisions that revolve around it. But I think everybody's kind of migrated to Postgres these days. Oracle, the reason they have so much money is because they made a database system. And then everybody has been forced to keep using it. But SQLite is one of those things that everybody uses. And I will teach it to you now. Bless you. So yeah, SQL stands for Structured Query Language, and it's just a way to talk about a bunch of data. Because a database is just a fancy file that lets you go through your data and pick out pieces that you want very quickly and efficiently. That's all it is, all right? You don't use a CSV file when you have millions of rows of data. You don't do that. You put it in a database. It's I don't want to get into the nitty-gritty too much, but databases are arranged in a way that lets you search for things very quickly. So, for example, if you got some numbers as certain columns of your database, like you got a price column or something, it's going to store that column sorted so that you can search it quickly. Because you know that you can search through like a phone book. It's in alphabetical order. You can find things very quickly. Same is true for databases. It's going to store. It's just a one big file, really, that is in a certain order that lets you like search for things and insert things and remove things very easy when you have a bunch of data in mind. And it also lets you concurrently access. So like think about if you make a website, like the class website. Our class website, by the way, uses a SQLite database to keep track of your attendance. But you could use Postgres. You can use some other database. No big deal. But it lets you also like, you can imagine that multiple of you are going to go and click I'm here at the same time on the website. It has to be able to handle that right to the database at the same exact time. Like that's something that databases are good at. It's not just you like in one file, in one notebook doing something. It's like 100 people on Facebook, 1 million people writing to the database, reading from the database as they click their mouse buttons and things, right? So it's got to perform. That's kind of cute and cool to think about. So yeah, a database has a bunch of tables. So that word table, it is something that is a real word in the real world. So a database has a bunch of different tables. You make multiple, usually. And SQL is just the language that you use to talk to a relational database, which is the most common kind. All right. And so there's essentially code that you write to like insert new rows, edit rows, remove rows, and like extract pieces. So I would like you, please, to try to go to this website. It's called SQLite Online. It's just like a little interactive place on the internet that lets us have like a little mini SQLite database. And I'll zoom in for us. So I will post some things for us to use, maybe on the written nice page. Here, I'll clear it out, and then here's like here's the website. So you can go refresh the page. It'll be there. You can go to that website, and we can follow along together if you'd like. So by default, this page has like a query. This is a database query, and it's giving you back some answers. Showing you the output. I wish there was a better way. Can I change the font size? No, I'm just kind of forced to have this font size, aren't I? Whatever. So like here's this row is like it's like a text editor where you put your database SQL query and then you click run and it runs it. And yeah, there's no table called ratings right now. It'll be something different for you probably because I was playing around. It's like select star from demo is like their default one, and they've made like a default table in the database called demo. But like let's make a blank slate and we'll go from there. So if you say there's a table called demo right now that has, you can click on it to see more about it. It's got three things, three columns, an ID, a name, and a hint with weird words. And so if you say select star from demo, it gives you all the rows from the demo table that's just like baked into this website. And so it shows them all to you down here when you click run on it. Usually there's an identifier name for a unique identifier for each row, so that helps you move around quickly. Like, all right, there's up to 27 rows, indices, yeah, 1 to 27. There's a bunch of different things. All right, so yeah, to get a blank slate, let's empty the database. You say drop table demo because that's its name. And you say semicolon. You say semicolon in SQL to end a thought. It's like a period. There's no equivalent in Python, but you have to say that in SQL. So if I say drop table demo, and it goes away on the left, there's nothing called demo anymore. So now we have an empty database, and we can populate it. All right. So yeah, I'm just going to show you a bunch of stuff. Here is the cones table and another table based on. I'm going to make a table called cones and a table called ratings. And here's how you do it. You have to be very precise. Python, doesn't really care about the types of things. It's all implicit. In SQL land, in database land, it's very explicit. So if I want to make a cones table in the way that we have, I say create table cones. And these keywords in SQL could be all caps. You'll usually see them in all caps, just like to mark that they're keywords in the SQL language. They're not actually something that I care about right now. That's like part of the name of the label or the table itself. It's like all the blue stuff could have been all caps, and honestly on the website it's going to force it to be all caps when you type it, just to prove that to you. So this is how you make a new table. You say create table, then you give it its name. So this is now is lowercase cones. This I could have said capital something. This now depends on the capitalization that you use. And then you put some parentheses, and you always end a thought. You always end a thought with a semicolon. That's always there. Always end every thought in SQL with a semicolon. It's like a period. Now I'm done thinking. On to the next thing. On to the next thought. And then in between the parentheses, you say what you want that database to look like. What columns will it have? So you say, all right, there's going to be a flavor column, a color column, and a price column. And here are the types of things I'm going to put in those columns. Flavor is going to hold text. Color is going to hold text. And price is going to be a number that has decimal places, which we say real. The opposite would be int. So we know int, but real means it has, it's like a float. Okay? It's Python's version of float. So yeah, that's how you make a table. You can also make a table called ratings, so I can show you how to join stuff again, because that's the thing in databases. Create table ratings. Flavor is going to be, we're going to match flavors to the ratings of those flavors. And we'll say int for ratings, only whole numbers of stars or something. And so that makes the tables themselves. And then if you can insert values all at once into the table like this, you say insert into the name of the table, and then here are the values. You have to say the word value. It's very old-fashioned, but it works like this. And they say a bunch of parenthesis delimited things, like here's the first row, and you give it in the order of the columns that you've declared. So strawberry, pink, 355. That's the first column. Chocolate light brown, 470. That's the next one. You comma separate all that. up to the last semicolon. You do the same thing for the ratings table, and that fills them in. Does that make enough sense? It's just new syntax, but it's the same ideas of everything we've been doing in this class. That's how you deal with the database, and then you can interact with it quickly. So here, let me paste all this for you on the written nice page. Dun, dun, dun. Honestly, don't know if I made that work, but we can try. Probably won't highlight it properly. So there's that one. There's these. So we'll just do them all at once. Dun, dun, dun. Submit. Oh no! Of course, it does weird stuff when I paste. Sorry, it's taken and made some weird characters there, as it loves to do. Is that just like a quirk of the way that I've pasted it, or what? Let me try to get rid of those weird characters for you, sorry. Because I see them. I see them when I press submit, but not when I... Okay, apparently now it's fine. So you can refresh the page or just like wait 5 seconds, it should work again. So here's all that. If you paste that into the website, boop, it's got all these things. I don't know what these... Oh gosh, are those other things that are not actually things? No, apparently that worked. I don't know what these red things are doing. I guess it's marking like extra space, maybe? I'm worried. But it worked out. It worked out and it says, all right, create table cones, create table ratings, insert into cones these values, insert into ratings these values. And so now you see once you run that, dun, 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 it's going to populate the table with all these values. And if you press it twice, honestly, it's probably going to add these again. And so it is very possible that I've put a bunch of things into here now. But like if you press play, like you're good to go. You got it. You now have a cones table and a ratings table, and no others if you dropped the other one. Okay. Any questions so far? Yes. To view the table, we have to learn syntax to print out things of it. You can't just see the whole thing because usually you imagine that it holds like billions of rows. You don't even. It doesn't even make sense to want to see the whole thing. Yeah, good question. So that's where we're going. The very first thing I want to teach you is how to print out stuff from the table. So I'm just going to go through all these things. I'll have this open on my other end maybe, but here's like all the things I want to show you today. I'll paste them onto that page again, and then I'll just we'll go through them one by one. So there's those, and in no real order. These are all the things I want to show to you. There's a bunch of ways to, these all look normal, good. There's a bunch of ways to get stuff out. That's the thing that we care most about. And they all start with select. So that word is a word. That's an important word. It's a database word. That's why they're using it in the data science library. Select gets stuff out of the table, and then things that don't start with select change the database. You got updates, you got deletes, and you got drop. I'll show you all those ones. All right, but select is obviously the most important one. So, because usually you're going to reuse all the data that you put into it. So here, you've got all that stuff. Let me look at it over on my own end so that I can follow along. And I'll just go through them one by one. And that'll be it. So, all right, I've got a blank query. What I'd like to do is, all right, I'd like to view the entire cones table. That's something you can do if it's short enough. Otherwise, you'd want to limit the query. There's a way to say that. But if you say this, you say select. Always starts with select. I want something. Select. Select it out. Select what do I want? I want everything. Star means everything. Select star from, where do I want it from? Which table? From cones. And then you say semicolon to finish the thought. So run. That prints the entire cones table. Does that make sense? I want everything, every piece of the cones table right now. Give me it all. So that's probably the most simplest way to pick something out of the database. If you just wanted a few, you'd be like limit 3. That's a thing. If you had like a million rows, you would want to add a limit, or else you would crash your database. It would just be printing all day long. So we have a small enough table that it's fine. Also, if you do Shift-Enter, it presses play for you, which may make it faster to go over stuff. If I just wanted a couple columns, I could say select just those columns, and I comma separate them. Select flavor, and price from cones. And it would give them to me in that order. If I said price, comma, flavor, it would give them to me in that order. That's every row. From the cones table, here's the pieces I picked out, and they're in this order. The first thing in the output table is price. The second thing in the output table, second column, is the flavor this time. So it could have gone in any order. All right. Do you see this? How the syntax is working? It's like select what do I want to select from, where do I want to select it from, which table. So it's very, from the 70s, still around. Everybody's learned this and they like it, apparently. So I can take those, select flavor and price from cones. Another easy thing to talk about next is sorting. So like select all these things from cones and then order by. That's their version of sort. Order by the price column, please. And so by default, it's ascending. It's ascending. And so this is optional in that case. It's ASC to mean ascending. That was the default. If you want it descending, you say desc, DESC. So there it's going to sort by the prices descending. And so that's something useful. So like if you wanted like, I don't know, the three most, what is it? If you wanted the flavor and the price of the three most expensive ice creams, you'd say select flavor price from cones, order by price descending, limit 3. It's like there's a long chain of thoughts, and it usually has that order. Like what do I want? Where do I want it from? How do I want to order it? That's kind of the name of the game. You can sometimes move them around, but honestly, that's the way I learned it. Like, can I change those? No, it has to be in that order. Like you have to, there's just a way that you learn to think when you're talking to databases, and I have it ingrained and I can't fully explain it. It's like that's the order of those things. Select something from somewhere, order by this. You can search SQLite select statement, and it kind of shows you how you could formulate it. Like there's a documentation page. It's like this is how you do it. Sometimes you could say with at the start, but it's like, all right, select something, column, some columns maybe, or a star. From has to come next. Then where, there's a where option comes after that. Then it's group by after that. Then window after that. And then order by after that. And limit comes after that. That is the order of your thoughts, which is fun to think about. That's kind of cute and cool. All right, we got those. And just shout out if you have any questions about this stuff. It's fun. One day you'll take a databases class. So you got those, order by price, descending, boop. We got those. You can also extract stuff. You got your .wheres. So like select, that was my next example. Select everything from cones. That just shows you all the columns, right? Show me the ones where the price is above $4. Where, select everything, all the columns from cones, where the price column values are greater than or equal to 4. And there it is. I'm pressing Shift Enter to run it very quickly, but there they all are. All right, and again, you could then order by price, ascending or descending. You can do all those things, and this is how you think and talk to a database and get out those pieces. Okay, so there's that. There's also like pseudo operations. Like you don't have to output just columns. You can do operations on those columns. So like, tell me how many. How many cones have price above $4? We know that there's 1, 2, 3, 4, 5, but you can check that. You can say, give me the count of all of the columns is kind of how you think about it. Give me the count of all the things from cones where the price is above 4. And so count is like a little function that operates on rows. It's like there's 5. There's 5 things with the price bigger than 4. See that? Or equal to. That works. Yeah, there's no real concept of just a single array or something anymore. It's like select star from cones. If you just want one thing, you say just select that thing. It's like flavor from cones, please. And it gives it to you as just like a table with just those things. All right, there's those. And you can see how you got a bunch of duplicates because you had a bunch of cones that were all of them were, 3 of them were chocolate, right? 2 of them were strawberry, right? If you want it, excuse me. If you wanted, just like, I want to know all the different kinds of flavors, you could say select distinct. Select distinct flavor from cones. Like, give me all the things from the flavor column, and don't show me any duplicates. Show me just the difference ones. So you can do that. All right. So that will show you how many there are. There's strawberry, chocolate, vanilla, bubblegum. There's many duplicates of some of those, but those are the actual ones. Okay, does that make sense? There's other little pseudo operations, just like there was count. There's average. There's other things. So you can say select. Give me the price column from cones. Give me, instead of the actual price, give me the average price from cones. So I'll go over them all and do that calculation for us. And then there's a way to round it, but I've forgotten how. All the different databases have different ways to round. It's like sometimes it's just like round that, and then you say how many, but probably not in SQLite because I'll get it wrong. Okay, that apparently works. Nice. Round it to 2. There you go. Nice. So there's things that you learn it once, they come back to you. It's like riding a bike. Great. There's that one. You can then another thing that we want to do, we like to be able to group stuff, right? Group and aggregate in our data frames as well as our tables. So there's got to be a way to do that. So let's do let's do flavor and price from cones. That was my example. That's all in that file that I gave you on the written nice page. So here's all the flavors and all the prices. What if I wanted like the average price of each flavor? Does that make sense? Like, give me the average strawberry cone price. Give me the average vanilla cone price. Average chocolate cone price. The way you do that is you group by the flavor, right? And so group by happens after the from. So select all this, group by the flavor. So you say that. And then by default, it's just going to pick one of the prices, which is not useful at all. It's going to pick one of the prices and show it to you. Instead of saying give me price as well, what you say is you apply some aggregation function to the name of the column that you want to aggregate by. So I want the average price after I've grouped by flavor. That's what it gives you now. So select flavor and the average price from the cones table after you've grouped by the flavor. So like here's all the bubble gums, here's all the chocolates. It's grouped all the chocolates together and it's taking the average of those prices of the grouped chocolates. Can you kind of read that? So it's all what we know. It's just like for pandas. It's just another way of talking about it, new words. All right, but this is the original stuff. This is very old, and everybody still uses it, so it's good to learn. So there's that one, and then probably the most exciting one that we could do is a join. So let's join. That's the whole reason I made a ratings table. So select star from cones. You get all flavor, color, price. Ratings has flavor and a rating. Let's take everything from the cones table and attach to each row the rating for that flavor. That's what I want to do. Attach a ratings column here, where strawberry has a rating, chocolate has a rating. Something like that. All right. So the way you do that is you say select, let's just give everything back. So select star from cones, and I'd like to join cones. Like this is not like, it's like I've not finished the thought. Like I've not said what I want to select from yet. You can think about it as one big table. Because cones is a thing, ratings is a thing. I want to join the tables together where their flavors are the same. Okay, so I say I want to select everything from cones join ratings. And that's what we want. And then you got to say what's the column you want to look at and see where they have things in common. I want to look at the flavor column of the cones table, and it's also the flavor column of the ratings table. It could have had a different name in ratings, but you say join rate. I want to select everything from cones join rating. Like that's a thought. Cones join rating is like a new table. It's a combined table, and we're going to join on is the preposition we use there. We want to join them on the place where they have flavors in common. So cones and ratings both have a flavors column. So now it's ambiguous if I say join it on flavor. That's not useful enough. So I have to say join it on where the cones dot flavor. You can be specific by saying it's that table dot the flavor column for that one. Join it where the cones dot flavor column values are equal to the ratings dot flavor column values. That's how you do it. And it's just a single equals in SQL land. There's no difference. There's no double equals in SQL. It's just like that's their equality check. There's their mathematical equality. That's how you do it. And that will attach all of the ratings table, everything but no, it'll attach the whole thing. Excuse me. It'll attach the whole ratings table. So this is select everything from cones join ratings. Think of that as one big table with all the columns together. And then here's how I want you to attach them. Attach them and join them only when the flavor column of the cones part matches the flavor column of the ratings part. That's when I want you to combine the rows, please. Does that make sense? That's how you do it. And so, yeah, that's how you get everything. And so we've attached ratings for every thing, and then we're seeing flavor twice now because it's just giving both of those, all the rows all the columns of each table all at once. That's what it builds you, like a super table with both of the table's columns. So that's a join. Usually you don't want to see this extra flavor. You just wanted something different. And so instead of saying select star, you can say different things. And now you know this dot syntax to tell you what you want. So select. Let's say I just want I don't want to see this flavor again. So like give me flavor, give me color, give me price, give me rating. But still this flavor is ambiguous. Whose flavor did you want? It's not immediately apparent to SQL that, oh yeah, they were going to be the same anyway. So give me somebody's flavor column. We can say, give me the flavor from cones. The rest of these are specific enough. They only belong to one of the two tables. So it's happy that way, but you can also be more specific. I want the color from the cones. I want the price from the cones. And I want the rating from the flavor part. I could have also said, give me the flavor from the flavor. That's the thing. Or sorry, excuse me. From ratings. And I did this backwards. Ratings.flavor. Like that would have worked. Cones.flavor. They're the same because we joined them where they were the same. I think that's what I wanted to say. And so this also could have been on separate lines. Unlike Python, SQL doesn't care about where you put new lines and spaces and things. As long as you end your thought with the semicolon, it'll figure it out. So like that can be on multiple lines. It's like that. There's like your three thoughts. Select these things from this combined table, and this is how I want you to combine them. That's how you can think about it. So yeah, I think that's what I wanted to say. Questions? Yeah.
Could you also, instead of doing select all that stuff, select star and just have drop?
There's no real concept of drop anymore. You have to say what you want rather than what you don't want. Yeah, unfortunately. You have to spell out exactly what you want here. And that's probably good for documentation purposes because like it's very apparent what you're getting at when you say exactly what you want. But it does make things wordier. That is true. Good questions. Other questions? Because that's most of what I wanted to show you. For selecting is what you're going to do all day long. It's usually somebody gave you the data, you go pick out what you need. You can turn your queries results into CSV files. You can throw those into your pandas library at that point. That's always possible. There's ways to do that depending on your database. And yeah, the last things that I want to show you is how to change the database. Like you know how to insert new stuff. Like that's a way. Insert. If you want to modify the database, you can do this. You say update to change a row or multiple rows. So here, here's a way to change every color where there's a flavor equal to something. So you can it reads like English. That's why SQL is still so popular. So what this line is going to do is like update the cones table. And I want you to set the flavor to dark chocolate wherever the color is dark brown. Does that make sense what it's going to do? So if I go to select star from cones, you've got a few dark brown chocolates here. I want to change those columns, that one and that one. I want to change them to dark chocolate just to make it clear to the person that it's a different kind of chocolate. All right. So the way we do that is we say update the cones table. I want to set the flavor to, just equals, sets it to dark chocolate. Strings in SQL land are single quotes only. It's a very old language. It's similar to Python that you don't have another option. There's no double quotes usually. Some languages do support it, but you got to get comfortable with single quotes for strings in SQL land. Maybe it was invented by a British person, perhaps. Set to dark chocolate. Set flavor to dark chocolate where And then you give a where to pick out the rows you want to update. Where the flavor, or sorry, where the color is equal to dark brown. And so that is by default going to mess with this one and this one. Does that make sense? Because that's where the where would find those rows in common. If you wanted to just mess with this one, you'd have to be more specific. Where the flavor, or sorry, where the color is dark brown and the price is $5.25 or something. Like that would pick out just that one at that point. And that's why in that original table, there was an ID column. Because if you give a unique number to everybody, you could just change it by the ID at that point. But this will change 2 rows because of the way we're doing it. This where is going to pick out 2 different things. So there's 2 dark browns. Right? It'll match both of those. So if you run it, there's no output because you're not selecting anything, but it made a change. So now if I select everything from cones, you see that we've got 2 dark chocolates now. Oops. 2 dark chocolates wherever there is dark brown. That one and that one. Okay. And that's pretty much it. Everything else is just like you want to delete a table. If you want to delete a row, I guess that's the thing. If you want to delete a row, you're done with it. You say delete from, name of the table, and then you give a where that specifies the kinds of row or rows that you want to delete. So if you want to be specific, usually that's why you have an ID column again. Like delete it where the ID is 5. That way you get rid of just one row. But you can say this, delete from cones where flavor is bubblegum. It looks like there's only one bubblegum anyway right here. It will get rid of that row. It will no longer exist if I say this. Delete from the cones table where the flavor is equal to bubblegum. And if I select star from cones again, you will see that there is nothing with bubblegum in it anymore. It's all gone. Okay? That's deleting rows. If you want to delete an entire table, you say drop. Drop table, give the name of the table. Like I'm done with the ratings table, I did my join, I don't need it anymore. You say drop. Drop table, ratings, semicolon. Then you're going to watch it go away. Boop. So now it's gone. If you try to select all from ratings, be like, no such table. It did the job for you. Yeah, that's how that works. And I think that's more or less what I wanted to say. So you want to deal with a lot of data at once. You're going to have to learn SQL and get out the pieces you want. Then you could turn it into maybe a CSV file that you could read into Pandas or NumPy. There's also ways to interact with the database in Python and then bring it in memory, like your queries result into Pandas or something. That's all possible. But that's kind of the trick. I hope that made enough sense. Are there any questions about any of that? Yeah.
Can we just use them in the terminal, or I'm assuming we don't use Jupyter Lab?
For like databases? Yeah, that's a great question. There is, so at the end of the day, every database is, do I have this installed? Of course I don't. Give me a second. Every database is a terminal command. Yes? In a sense. So like SQLite is a database. Usually, for SQLite databases, they're simple. They are actually files. And you can see which file it is. Like I can say, you can interact with it through the terminal. There's always a way to do that for every kind of database. Like there's my cones table. Put some stuff in the cones table. Boop. Select star from cones. And it prints it out to you in a text-based way. And if I get out of that, that was an in-memory database. If I did that and I gave the name of a file, like let's go somewhere else. I'll call it SQLite 3 cones.db. Like it'll work on a file. That's what SQLite is all about. So make that. Do that. Select star from cones. Like it works. It made this file called cones.db, which is a certain size. It's got it's 8 kilobytes in size. It gave it some extra space maybe. So you would interact with any database. There is a way to do it on the terminal. There are also, for every other kind of database where it's not really a file, like it's managed for you, like the MySQL, the Postgres databases, the Oracle databases. That's managed for you, and you connect with that over a network connection, even if it's running on your own machine. You connect with it on your machine's local network or across, because it's probably on a huge server somewhere. So you connect up with it through a network connection. It would still be, you can still get to it with a terminal command and interact with it on the terminal, but there are libraries. There are libraries to interact with it in different ways. So like there's like graphical programs that let you run queries like this that you just install on and like tell it where the database is, give it the network name and everything. There's also I don't know, Python, SQLite library. You can connect to any database with like a Python library. There's a SQLite library. There's a Postgres library. So you just say like where it is. So in SQLite's case, it's going to be a file, and then you can say .execute, and you can get things back as Python objects, which is nice to think about. And so that means then you can interact with a database from a Jupyter notebook. You import the library that deals with databases in Python. You can do your query in a cell. You can get the answers back and maybe shove the answer result table into a pandas data frame. That's all possible. So I guess the answer is it depends, and you can do it in a bunch of different ways. Does that make sense? Yeah. You have options. People have tried to make it easy to connect to a database and do stuff, whatever you want to do. Yeah. Other questions? So yeah, you've got a sneak peek of what's coming to you if you want to keep on going with data science. But I hope it's quite nice and not scary. It's very similar to everything you've learned in this class. Although all the names are the same, they use the words that were the right words to describe what you were doing. Other people use those words. So yeah, that's good news. I won't test you on any of this, and I think that's all that I want to record for the day.